This is a Group 2 demonstration of our first project. What you see here is our module 0. I am acquiring data, which is a 1 kHz sine wave. You see the waveform and the Fourier transform peak. As I slide this to 2 kHz, you can see that we are seeing the peak slide. I can go back to 1 kHz. Just to demonstrate that we are scaling everything correctly, I am changing the sampling rate to 5000 Hz. Even though the extents of the Fourier transform graph have changed, the value is still correct. I can still go to 2 kHz. I can still come back to 1 kHz. In the same way, changing the samples per channel does not negatively affect the data values we display, even though it does change the number of bins in the Fourier transform graph. I'm going back to 1000 samples per channel and 10,000 Hz sampling rate. If I switch from a sine wave to a triangle wave, you see different peaks. Square wave even gives more peaks, and shifting the signal also has the desired expected effect. I'm switching back to a sine wave. Our VI is configured so that when I hit stop, it will ask for a file name, giving it a default of capture.csv, and I will say OK. To demonstrate that we can read from a file, we say display acquired data, run. I will open something else, just so you see that we're not just displaying the same thing. So there is a file called input.csv. As you see, this is a square wave with a little bit of noise that I've added, and you see the 4 Fourier transform peaks. And we can run this VI again and go to capture.csv and open the file we just captured. That is, open the last 1000 samples of the file we just captured. To see how our VI works, I will go to the block diagram. Unfortunately, in Labview, we don't have a zoom feature. If we do, I don't know where it is. I have a while loop that runs until we hit stop. We specify the rate and the samples per channel. There is an operation mode selector. For the default mode, it's acquire data. If we want to go to something else, it's open file. Either way, we are outputting array and Fourier transforming it. We are displaying the acquired with a signal waveform here. And outside our while loop, and just another detail of our program, once we Fourier transform, we realize that we have to scale the x-axis of the Fourier transform graph. So I will open display context help. What we have is the FFT widget. I'm extracting I'm taking its absolute value. I am putting that in the y-axis of my Fourier transform graph. For the x-axis, I am extracting the size of this array, getting a subarray that's half the size of that array, and building an x-axis that's transformed by the sampling rate divided by the number of samples. So, one becomes, if sampling rate were 10,000, number of samples were 1,000, our scale factor would be 10, so that we would be scaling index 1 to 10, index 2 to 20, and so on. And I am showing this in a two-dimensional graph. Once all is done, we have a case statement. If the mode was acquired data, which in this case it was not, I'll go back to this. Our file save logic runs and extracts a portion of the signal and specifies the default capture file, allows the user to override it, creates it, and saves it. And once again, this is Oğuz Yetkin from Group 2, demonstrating RVI. Thank you.